Good morning, everyone. Before we get started, I would like to take a moment and introduce our trainer, Suresh. I'm happy to introduce Suresh, who is currently working in Amazon and he has 18 plus years of experience in IT. Who has deep expertise in AI and Gen AI. He has been involved in multiple real world AI projects. He has strong hands on experience building the real world AI solutions that make an impact. We are really excited to have him us and looking forward to learning his expertise. So let's warmly welcome Suresh. Suresh, over to you.
Yeah, thanks, Venkat. And hey, everyone. Good morning. This is Suresh. I think Venkat has already given me a quick intro. That's good for me. Just to set the context for this particular demo, I think as Venkat has mentioned in the beginning, it's a mix of last two demos that we have discussed already. But in case there are any specific questions, yeah, we can go deeper. In the intro part, yes. So I'm with Amazon and I'm working on the AI, classic AI and generative AI kind of systems since last 6 years. So I was with Alexa, and now I'm working with AGI, which is artificial general intelligence, which is a kind of a core area for all the generative AI and advanced AI technologies across the industry. Okay, so with that intro, since it's a very short session, so let's get into the details. So can I know how many of you are completely new who haven't attended any of the previous two sessions?
I not attended, Suresh.
Okay, Chandrasekhar.
Suresh.
Okay. Got it. Okay, I think very few.
As for my knowledge, very few are joined the first time, except two. I think only 2 or 3 are joined. Remaining all are not yet attended the demo. I think most of them are new here.
Got it.
Yeah.
No problem. Okay, so let me quickly set the context of the demo so that we don't get deviated. So in this demo, so the idea is basically to introduce you the evaluation of the AI, like what the AI used to be for the over a decade time. And with the inception of ChatGPT, predominantly 2022, though the initial research started long before, how the spectrum, how all the calculations have been changed since then across industry, not just for the learning side. And we'll focus on the evaluation part to understand the connect between the classic AI to generative AI. And then we'll also discuss how generative AI works on a very surface level. It's hard to go deeper, but we can touch into how generative AI works overall, and the applications of generative AI, and most importantly, the roles of generative AI. So this is a very big area. So in the sense, many technologists compare generative AI or LLMs to electricity or the internet, or on a lesser side on the entire mobile. So it's much bigger than that as the future evolves to be. So we'll see what are the different roles in it. We will not be able to cover everything about generative AI. So where should we focus more on based on our interests, strengths, and the goals? Okay. So having said that, let me quickly jump into sharing my screen and then start. Okay. Let me know if you can see my screen. Can you guys see my screen?
Yeah.
Yeah, yes, Suresh. We can.
Got it. Cool. So jumping into the next. So we mentioned about the connect. We discussed that. We'll cover the journey of artificial intelligence overall. I think some of you may have already worked in the artificial intelligence and some of you may not. But so far, this is the whole big balloon that got expanded into the more core more advanced kind of artificial intelligence. So that overall general artificial intelligence, which has been started almost like a more multi-decades back, right? And then we predominantly what we have seen is the machine learning part. I think many of you have actually used the machine learning modules, packages that already integrated into Python. The Python has a lot of packages that where we have actually tried with a lot of machine learning algorithms. And then we advanced into neural networks, maybe close to two decades back. And then we have learned a lot of algorithms on the neural networks, where basically it's took the overall machine learning to a next level with millions of neural networks integrated together, and then how efficiently we can analyze the patterns, and then we can do the recognitions, we can do the classifications, and a lot of stuff. And then with the help of the neural networks, we entered the deep learning, which is I would say, a pivoting moment. Deep learning has changed a lot. In fact, the current generative AI also, the deep learning is the very base. So all the algorithms that we have in the deep learning, so they have been being continued evolving into what we now is calling as generative AI. It's based on that. So with the art classic AI, we were able to do a lot of applications that you can see in the left side. So we are able to do computer vision, we are able to do pattern recognitions, and which we are actually using into augmented reality, security surveillances, and in fact, in some of the medical diagnostics as well. And on the other side, we are using these machine learning models for natural language understanding, text to speech to text conversions, on the language translations, and respected decisions makings. Basically, we are able to build chatbots, majoritarily basically based on the rule based. So what does it mean is basically we give certain rules to the chatbots, and then based on those rules, chatbots work. If you completely move out of this and then ask a completely different question, those doesn't work as expected. And we advanced till the fact that we are able to do actions and triggers. So just before the generative AI, we are in a stage where the classic AI is able to kickstart some actions based on some rules. Basically, booking a ticket or something, given certain rules, certain criteria, certain conditions, and the dynamic input. We were at that stage. But in 2022, basically when ChatGPT has been evolved as one of the general purpose generative AI based application for all, then the entire paradigm has been changed. Now, let's connect this to generative AI. So what's generative AI? What's LLMs? So let's understand this and then impacts, and then we'll go into the details. Built on top of the overall deep learning.
Suresh, one question here. Sorry to interrupt. Actually, in the previous slide, you were talking about the pattern matching, right? Like pattern recognition and pattern matching, right? So, how is this pattern matching related to AI?
Okay. So what is AI? What does neural networks do here basically is to understand patterns. What does it mean by pattern? So for example, if we say, let's say computer vision itself, thumb impressions, for example, and then image recognitions. So by giving multiple pictures, I'm just giving an example, by giving multiple pictures of you, for example, can this identify a new picture? Is it your picture or someone else's picture? So what it does is it splits our entire face into multiple quadrants, and then go into the deeper into smaller quadrants, which at the pixel level. It understands the patterns between subsequent pixels, for example. So what is the value of our left side pixel, right side pixel, and so on. That's how it generates, understand each image, and then it generates the patterns between multiple images. And then it learns with the neural networks helps. Basically, it learns a lot of such pixels and the patterns, and then it stores that information. Whenever we give this new image, it sees whether the values of the pixels and the new image versus what it has learned before matching or not. That's what the pattern recognition. For that, it has to learn, basically, with the help of a lot of neural networks.
So now, continuation question on that. So when we recognize the pattern, right? Even the chat GPT inside the technology is to recognize the things, or if I take the like last time you gave an example of image comparison, right? So internally it will again use the same pattern recognition techniques.
Yes, yes, that's what I'm saying. So basically, generative AI is built on top of overall deep learning. So what does that's been built so far, invented so far, is still true. It's not that whatever we have done so far is incorrect and we are moving to something else. But generative AI and LLMs can do a lot more than what they are doing, which we can cover subsequently.
Yeah, thank you.
Got it. So moving to the generative AI aspect. So why do we call that as a generative AI? So far we are calling like multiple things, and artificial intelligence, machine learning, and overall a lot of different aspects. So what does generative AI, as name it says, as probably we discussed multiple times already, it's able to generate the content. That's a key difference between the artificial intelligence models so far and what we are currently discussing with the generative AI. All the algorithms and models so far, they are able to process a huge, humongous amount of data, and then they try to find patterns among them and the entire database, then try to identify any kind of outliers and then fill the gaps kind of a thing. But this is a big change where instead of analyzing the existing data, we are able to generate the new data, new content. And that's why you see, and when this capability is being given to the end users who is completely unaware of this computer science and as well as artificial intelligence, then the usage and applications become multifold. And that's where the whole traction that comes towards generative AI and LLMs. So any end user, naive user can actually generate content. So that's why the power of generative AI is multifold. So what are the critical components behind this generative AI is large language models. So to understand large language models, let's understand language model. What is language model? Language model is an artificial intelligence technique which is basically used to generate the natural language, the natural human language. Because of the limitations of the technology or the compute power we have so far, these language models are limited to certain length. So it could generate, say, one sentence or a couple of sentences over the research. But with the change of technology and the algorithms and the transformers, we are able to generate the text to any extent. Not only that, we can generate any type of content. We can get into the details. Now, with that large language models evolvement, so you're able to get into the generative AI phase where we are able to generate text, images, voice, videos, music, and anything. So by using the classic techniques behind the scenes already, but just with an advancement onto the existing algorithms. Then we are getting into the agents and agentic AI. So we covered about, okay, we know a lot of machine learning models to understand, do the pattern recognition and everything before, and then we are generating the content on top of that. Now what next? So the next is generative AI can generate the content, whatever you ask for. You ask a question and then it can generate the content, which is a advancement. The agent is basically not only generating the content, but can also take an action. Say, for example, hey, before that, we were not able to generate any content. Now it's a generate a video, for example, generate a reel. Okay. And then you generate a reel. And whenever there is a discussion happening around the content of the reel, you publish this reel. So that's what you're saying to an agent. Now, what this agent does, for example, if you have an agent of yours in your, say, for example, Facebook wall or a Twitter or an Instagram. So assume that you have an agent which is listening to all the conversations happening. And then if there is a conversation about, say, for example, generative AI, then it could publish a reel which is generated automatically. That means you're not only generating, you're also automating the things. That's about the agent. Agents means is autonomous. They do take actions on top of them. Taking actions is added additional functionality on top of generative AI makes it an agent. So the agentic AI, it's basically like multiple agents involving this discussion. For example, I just gave an example that you have an agent on your Instagram, LinkedIn, or whatever, right? So your agent works basically based on what you have prompted to it. We'll discuss about the prompting. You prompted your agent that do something, generate something and do something for certain situations. Similarly, I may have my own agent, or Venkat may have his own agent in the same Instagram link setup. So we three manually, no need to do anything. So there could be some content floating around in the Instagram. Based on that, our three agents, if they generate and then publish the reels, and they keep growing. So in this whole concept, I'm really worried about the amount of data that it gets generated. Already it's a huge to manage, but now it's automatically we are generating the data. It's crazily beyond our imagination. That's about the agentic AI. That's what actually happening right at the moment. So looking at the impact of overall this generative AI, you just look at the numbers, right? So since November 2022, the industry expectations are like close to 4 trillion annual economy being added across the world. And it's the global GDP itself is like 7% projected every year. And most importantly, 80% of workforce is getting impacted. In the sense, what does that mean by impacted? It doesn't mean losing jobs, but 80% of the workforce, irrespective of the domain, their jobs are being influenced to use AI. So that means in one way or the other, so we should get into the AI part. Okay, so that's what the current generative AI, LLMs, and agents. So what?
So one question here, Suresh. So how can we correlate the ALM and Gen AI and agents? I mean, if you take the core example like ChatGPT, the front end, whatever we are looking, is an LLM or it's an AI. How does it? I mean, I'm just trying to correlate the relation between these three.
Yes, I can go deep more into that in the subsequent slides, but to answer your question right at the point,
Sure, no problem.
GPT,
I
for
can wait.
example, is a ChatGPT or Nova or anything. These are like foundational models. These are the models built already to help you answer things and generate content. Okay, they are built on top of LLMs. LLM is the core functionality behind the scenes, which is helping these foundation models to generate the content. We call generative AI. For example, LLM, ChatGPT, and these foundation models are examples of generative AI models. And the underlying architecture is based on large language models. Now, with these foundational models, we can create n number of agents, and we can prompt these agents to do some actions and as well as talk to each other. Those are coming. So it's like one step forward. Like first large language models. On top of that, you are building generative AI. On top of that, we are building agents. On top of that, we are having agentic AI, where multiple agents talk to each other. Okay.
Mhm.
Cool. So that's what happening today. Like means many people are already into this space. They know agentic AI. They know agents. They know LLMs. They're working on it already. They're building applications already. If we start understanding and learning now, in the next 1 decade, probably or more than that, what is future? We discussed about we are generating the content. When we ask something, for example, say when you ask ChatGPT, can you generate a content about uh, all the people in India coming together and then celebrating an event, for example. So you're just trying imagining such a picture and then asking to generate. Yes, it can generate based on understanding the prompt. We can get into the details how it would be able to generate. But the next stage is dynamic and contextual content generation. So for example, you are not exactly saying what to be done, but you're just giving certain information only, but rest of the information is dynamic. For example, you're saying, consider your agent. So you're saying agent, hey agent, generate um, an image by saying wishes for the birthday, for a birthday or anniversary or a festival. You're not saying which birthday, whose anniversary, which festival. So you're saying that generate a nice contextual image and then send it. So what I'm saying is instead of generating the moment right at the moment, we are giving some context. Dynamically, it finds, okay, whose birthday it is, whose anniversary it is, which festival it is today. And then it gathers certain information around it, and then it generates image and shares it. It's a dynamic generation. And the second is advanced human AI collaboration. Today, for example, I could take Alexa as an human AI collaboration that they talk to each other, they converse. The new Alexa Plus that we recently rolled out is an advanced human AI collaboration example. It's not just asking question and responding back, but it's like more conversational. So it's like one human talking to another human. It's like a simulation of that with AI. And the third space is agentic space communication, which I just mentioned, like one agent talking to another agent. It's not just we create agent and that agent does some job, some action, but the agents talking to another agents, they themselves understand the real world scenarios, and then they act based on certain guardrails set around it to avoid any kind of unnecessary or unexpected events out of it. And the next one is artificial general intelligence. So there are a lot of companies already working on it. So basically one of the space I'm currently in is artificial general intelligence. What does it mean is today so far all these AI models and everything do certain level of human jobs. But they cannot do everything that a human can do by the reinforcement kind of a learning, because we can reason well. So we can quickly change the decisions. We can quickly move from one context to another context. We can get the memories from the deep from our thoughts. There are a lot of functionality that a human can do now that machines cannot. Artificial general intelligence is targeting to match what a model in an artificial intelligence model can equally perform as a human. And then the super intelligence is going beyond what a human can do. So going beyond what we can memorize, going beyond what we can reason and think, going beyond what we can perform from based on our humanly capabilities. So super intelligence. Artificial super intelligence is basically going beyond on and above beyond what human can do. So which basically Facebook has recently started this entire org, or Meta has started an entire org for this super intelligence. So this is what it's actually the advancements going on at this point. Okay, so let's step back from the future and then see what's generative AI currently at this point. So as we discussed already, it could generate text, image, and audio, video, or any kind of a structured text or something. So let's look at how that actually happens. So if we understand what happens behind the scenes for generating this, then we'll probably understand the overall how everything works. So can you see this picture? May not be the entire text, but the whole flow.
Yes.
Yeah, okay, cool. So this is how the LLM work. By the way, this is a diagram which is generated by LLM. Generative AI is not handmade based on what it does on its own. So this training phase, as someone asked about a while ago, how we relate the LLM models versus the ChatGPT. Let's understand this picture from this. There's two things. One is training phase and another is inference phase. So when you open a ChatGPT or Claude, and this is a place where you are opening it, right? Between this training and inference phase. In the training, a foundational model like ChatGPT gets trained on a huge amount of data. So the data coming from all the books, articles, and all the websites, anything that's available under the sun. So it basically uses the multiple millions of neural networks, uses a transformer architecture in between. We can go into these details during the coursework, what are attention layers and what is transform model, what is vector database and everything. But they use this technology and then the model gets trained. The model gets trained to answer your questions and as well as generate the new content. Now the model is trained, the model is ready, and ChatGPT is launched. for a general purpose usage. And then we are opening the web browser interface of the ChatGPT. By the way, it's not only the web browser. ChatGPT can be a web browser based, or it could be app based, or it could be have been integrated into your applications. Like say, for example, Microsoft 365 or Copilot. So these are the things that have been integrated into your applications as well. One way is web interface so that every end user, naive user can use that. Now you assume that you go to chatgpt.com and then did this, write a poem about blah, blah, blah. Then what it does, it tokenizes them, like, write a poem about, and then it basically splits every word. And then sometimes it splits one word into multiple tokens. For example, extracurricular. Extracurricular is a word in English language, but it gets split into extracurricular, 2 tokens. So because it wants to split the entire text that you have asked to it into multiple tokens, and then able to understand, correlate the relation among these tokens, and then it's able to generate subsequent tokens. That's what it's supposed to do for generation. How that it does is every token gets converted into a mathematical form, and then the mathematical form gets stored into a vector space, a vector database. Now, making relations in the form of mathematical forms is easy compared to text. That's why it gets converted into mathematical forms and stores. So it's easy to calculate the distance between one mathematical value to another mathematical value. So it stores all the relevant words together so that it can generate those relevant words when it's necessary. So we can get into the details of algorithm later, but so the point is it's able to, it splits on the entire tokens and it predicts the next token. For example, it says write a poem um, about the childhood, for example. Then it has learned a lot of content here in the training phase. So it knows there are a lot of articles about childhood. There are a lot of articles about kids philosophy, what kids do, what kids don't do, what kids ask for, all that information it has. So it stores also this information. And then when we ask write a poem about childhood, it gets all the relevant information about childhood. And then it slowly start understanding and then matching the patterns, and then as it says this, do the attention to those words, and then gets the relevant words, and then do the prediction. Okay, this is about childhood, or not, child can do this, child in childhood, child can do that, and then it makes a poem because now it understands about childhood word and then came up with the relevant other words. Similarly, it understands the word about poem and it comes with the relevant details about the poem. What does it mean by poem? Poem is different from an essay. Poem is different from say, for example, resume. Poem is different from a textbook. So what does the features of the poem? It brings the features of the poem and it brings the features of childhood. It brings the task write. It's not about read, it's about write. So it's not generating an image. So it understands that it put all these things together and then generates a poem. That's how it internally works. So basically, it internally uses a lot of LLM generation techniques for the new tokens. Basically, it generates a token for every different combination, and then finally able to generate a poem. Similarly, it does for images and videos as well. So in the last training, I showed how images can be generated. For example, I can say, I can show you this how images work here basically. So for like we use transformer models to transformer techniques or architecture to generate new tokens. It uses a diffusion model internally to generate the new images. So how does it happen is, I will see here, I'll just give an example here. Okay, let's take this. So the idea basically is it's able to generate, it's able to create more noise for understanding those images and then removes the noise for regenerating that image. Okay, let's take this. Yeah. Okay, look at this image. So there's a lady here. So it's basically what it does. There are a lot of plenty of images on the internet. It takes all those images and then it adds the noise to that images. When I say noise, it's not actually the noise. It's basically pixelate them. Like it just breaks into small pixels like this. And then it shows the relations between the subsequent pixels and the patterns. And then when we ask to generate an image, it slightly modifies these pixels relations and then regenerates. For example, if you ask you give this image and then say, hey, can you generate the same image replacing a girl here with a boy? So it's basically the facial expressions slightly needs to be nuanced, and then long hair has to be cut to short hair because it understood from a lot of billions of images that men usually have short hair, women usually have a long hair like that. So that based on the understanding of, based on the pre-trained learning of that images and then the, adding noise and then understanding the relations among those pixels, it changes here. For example, the rest of the features may be same, but in the hair here, somewhere here, it modifies the noise. It restructures the noise so that when eventually it will start removing the noise, by the time it generates the image, the face will be changed to a male here. That's how the diffusion models works. It's a forward diffusion and it's a reverse diffusion while regenerating it. So I'm not going too deep into that, but just to give a sense of how it happens. Now, coming to videos, probably you may aware video is like a multiple images put together probably millions or billions of images put together so that you see the action as an image, as a video. Similarly, the same diffusion model works even for the videos. So in this case, instead of working on one image, it works on say millions of images. This way, generating image, it takes a lot of processing and time compared to images and compared to text. Okay, so before I step into this this one, further enhancing results, let's quickly show something here. So I have this Claude, ChatGPT, Amazon Nova here. So the LLM models that we are discussing so far, these three are general purpose. Means you go to Claude, ask anything, or you go to ChatGPT, ask anything. Ideally it should be able to answer all that because these are general purpose. What does it mean is the training for these models happen across all domains. That's probably Sun. Was there a question? Okay. So for example, take Nova. So Nova has a option here to generate videos. Say, just wanted to show, yes. Yeah, look at this image. So all the images that you're seeing here are generated. So in the sense, say for example, let's take this example here. They may not probably be a video on the internet, which is like, preparing a pasta with mushrooms in it, and then there's a smoke coming off it, for example. Probably there may not be a video at all where we mix both pasta and mushrooms here. There could be about preparing a pasta, there could be videos about preparing mushrooms, but we are giving a prompt to it that say, hey, create a cooking recipe video where pasta with red sauce and mushrooms and coriander or mixed, and then it's almost done. And then it's, the fumes coming out and the texture is very nice and the kitchen is clean. So you're giving all the prompts. So based on what you're explaining that, it's able to generate text out of it. It's able to generate images and multiple images to generate a video. That's how it's a sequence of things work to eventually to come up with this video. Okay, so just I quickly want to show that. Okay, let's go into the other techniques. So I don't have a slide specifically for prompting, but before I go into the and fine tuning, let me introduce you to the prompting one. So what is prompting? Okay, let me spend some time here. So this is your Claude, or because if you are familiar with ChatGPT, let's take ChatGPT. So this is the interface for you to use ChatGPT model, which is pre-trained base model, foundational model. Pause. Okay. So there are multiple stages for a LLM foundational model for us to use. The first stage is pre-training. So whenever, for example, when OpenAI is trying to come up with ChatGPT, they need to train ChatGPT foundational model with a lot of content in the internet or whatever, the books or articles or anything. That's called pre-training. With pre-training, ChatGPT has a abundant knowledge about everything, but it may not have everything. It learns till the point what we have induced to it. For example, ChatGPT has launched a new version of ChatGPT has been launched today. That means it can understand and answer questions and then generate the content based on the data trained so far till today, because today is only the ChatGPT model has been launched. And any events that happen from today, ChatGPT may not be able to understand or may not be able to respond back or may not be able to integrate those into generation of new content. How does that can happen? Because of that, all these foundational models gets continuously trained every hour, every minute. That's where it requires a lot of compute power. That's what called a pre-training. Now, once it's pre-trained, it knows information, but how it can actually generate what you wanted. For example, let me take the same example. For example, this is my prompt. Prompt is like the input to a foundational model like ChatGPT. Now, when you ask, write a poem about childhood, it says, okay, it has given a title, nice, Whispers of Childhood. So, and it's basically based on the content it has learned so far. So it has generated a poem and it's mentioning about laughter rose like birds in flight. They are like in childhood fates, but never dies. So they have added some details. Okay, but it's a very generic poem. Okay. And we may not really need this exactly this one. So what we may need to update the prompt. So be specific about Indian childhood. So if you observe, right, I'm not giving the entire prompt again. I'm not saying write a poem about Indian childhood. So it's basically, I asked something, it generated something based on what it pre-trained. And then I'm modifying my prompt. I'm enhancing my prompt. This is what called prompt enhancement by giving more context. This is the context. The context here is Indian childhood. What is saying suddenly a poem about the specific child. Okay, it says under banyan trees, curd rice, mango pickle, like what we had in the childhood. So it started adding to it. Nice. Limit this to 5 lines. Okay, we further enhance the prompt to whatever we want. So it just generated into 5 prompts. Can you add a title to it in Telugu? So it just added the same 5 sentences. It just added a title, Balipu Nyapakalu. So it's basically, it's just like a iterative way of, prompting. We may not be able to get everything what we wanted in one single go, but it understands the context from one prompt to another prompt. We don't need to repeat everything all the times. Similarly, images as well. So this prompting is one of the big area for us to learn. No matter how many foundational models come up, like ChatGPT and Claude, no matter how much advanced it goes to, like agent to agentic, prompt engineering is the key. It depends on how best we give the prompt, that best it generates the whole result out of it. So this is one of the key area that we basically needs to continue further focusing on the prompt engineering. Now, I wanted to link this to the current, this one, for example, the RAG. So RAG, retrieval augmented generation, is a technique to further enhance the results coming out of it. Today,
Suresh, one question here. So when we are prompting, right, how do you know? Based on the results, I understand that because we have given a very simple example. So based on the results, we understand and we updated the prompts, right? But sometimes I may not be sure whether whatever is being generated in the ChatGPT is correct or not. So how can I make sure my prompt is correct?
Very good question. A disclaimer that every tool does. For example, like say you look at the last line here, ChatGPT can make mistakes. Check important information. Okay. So every foundational model does that because this is not something that accurately telling as in our textbook. This is just basically learning from a lot of resources and then trying to generate new content based on what it understands. Now, to answer your question, right, we should always verify the output coming out of it. You said that how my prompt is correct. It's not about your prompt is correct. It's about the response is correct or not. So prompt can be having, say, for example, it's like, as good the input is, as good the output is. So if you make mistakes in your prompt, for example, instead of saying about childhood, you said brotherhood, then everything changes. That's about the correctness of the prompt. But when you actually says childhood, and if it is saying about brotherhood, then it's a problem with the prompt, oh, sorry, problem with the model. That's what you need to verify at the end. Finally, when these file lines generated, it's your responsibility to verify everything before you use it for any kind of an application. There are various scenarios today when ChatGPT output is used as is in some kind of a financial and law. They were like beaten hard in the sense that they had to pay a lot of
Do
fines.
we have any tools where I can, I mean, at least any trainings where I can learn how to give the proper prompts to our engines?
Yes, there are a lot of prompt advancements techniques which we can cover in the coursework as well.
Okay,
How you can improve the prompt, how you can simplify the prompt, and one more aspect, right? You cannot give a prompt like say 1,000 lines or 2,000 lines prompt here.
correct. Yes, agreed.
The more the
So
prompt,
more crisp and more, I mean, I can say more crisp and more informative kind of stuff where we need to give us a prompt, right? When anything, whatever we do.
yes, because you remember the cost of this prompt as well. You're using ChatGPT here in this case for a free thing.
Hmm.
Eventually, for doing a specific work, you need to subscribe for it. You need to pay for it. How do you pay? You pay for the number of tokens that you use in your prompt. The more tokens that you use in your prompt, the more you pay. So your prompt has to be very crisp, simple, yet effective to generate what you want. So the reason they charge more for larger prompt is the more prompt you give, that means the more words you give, the more tokens you give. For every token, they need to see the inference, generate more variants, and then try to generate new content. So it has a lot of processing behind the scenes. That's why they charge more. So the less.
So the before diagram, whatever you showed, right, the LLM model that you showed it. So the prompt that we are giving will be broken into the small tokens, and these tokens go to the AI agents, and then it will search for the particular thing, and then it will display in this LLM, right? That's what the total structure talks about.
Yeah, yeah. On a high level, yes. How does it exactly generate the new token? It's based on a lot of algorithms, yes.
Okay, got it. Yeah.
Okay, that's about the prompt thing. So as I said, prompt needs to be very specific, very clear, very simple, short, and then to the point, basically. So there are a lot of prompt engineering techniques which we need to master on. That's a very important area. Now let's go back here. Assume that you are able to generate the content, you are able to get the right prompt, it's everything good, all fine, but it's not actually serving your purpose. Let me give an example. So I think let me take the same example that we have done last time. You're working here for a company and you're trying to generate quarterly results for that company. So now what it does is to generate quarterly results for the company, you need to feed in the results for the company. In the general internet, when this model, foundational model ChatGPT has been pre-trained, probably they don't know anything about your company because your quarterly results won't be there in the internet. or your company's information, confidential information, or what your company is working on a project for this year that may not be available some while ago when ChatGPT has been generated. So if you ask to generate can you generate a quarterly result for my company? Let me do that, right? Why not? Can you generate a report or quarterly results of my company? For example, let me say Amazon. See, so this is the information it doesn't need. Like it's a Q2 2025. What is that? What are the financial data? What is the format? It doesn't know. It cannot generate immediately. Ideally, my expectation is okay, it generates the quarterly results. I can publish that. Now, this information is not up to date with ChatGPT or anyone to any model, foundational model to that matter of fact. So that's where it comes to the RAG. Remember how powerful the ChatGPT is, that powerful RAG is. Because otherwise you can use ChatGPT only for general purpose questions, generating some funny videos, images and everything. But you cannot really influence or you cannot really change the world how it operates now. RAG is the biggest puller here. In the sense, you have your LLM, pre-trained ChatGPT here, for example, and then query is your prompt, response is your response. This is what we have seen so far. And on the left side, knowledge base and relevant context is what you are passing as an additional context to LLM, saying that, hey LLM, hey ChatGPT, this is my company information. This is my quarterly result information. This is what these are the projects we have done. These are how the financial results are. You are passing from your database, company database, and your RAG into it. That means the retrieval is augmented. Sorry, the retrieval is augmented with some new data. That means you're augmenting means you're adding, you're giving additional information for retrieving the right content. That's the RAG is. And based on this concept, most of the LLM applications are built in the companies today. Now let's confirm that. So assuming that we have given this which quarter, which details, projects and everything. Now it generates the quarterly results, but the quarterly results output may not be the same format or the same structure that you're using so far before the LLMs. Then you need to tell LLM that, hey, this looks good, the content is good, but this is not the format that we are using so far. It needs to be reformatted. It needs to be fine-tuned. For example, the number should not be displayed into millions. It should say 10M rather than saying the entire million digits. So it should not be into a tabular format. It should be in a descriptive format. So all that you need to, how do you explain in the prompt? You cannot explain all that in the prompt. And if you do that, the prompt would be like, 10 pages. For that, what you do, you show the previous examples. Like say you RAG, and in another branch, you say, this is your pre-trained LLM, and this is your custom knowledge base, basically, which is basically the custom knowledge is this one for RAG. And then the raw text data is what you are passing on. Okay. While you're passing on, you also pass the formats. Okay, show the numbers in millions M or B billions rather than full number. And you give previous reports as an example, as an input to it. Based on that, it fine tunes the results. This RAG example is to get the right content out, and this fine tuning is to, once the right content is available, how do you generate the right format and right structure out of it is the fine tuning. It basically works on the results. RAG is works on the actual content, while fine tuning works on the final results. So these two are important techniques that you need to understand too when you learn about LLMs and working with LLMs. So in the interest of time, I'm moving forward. Yeah.
Sorry, okay, Suresh, no problem.
No,
So
go ahead.
just a small question I thought of asking. So this rack technique, whatever we are talking about in this diagram, will be taken in the relevant content, right? Because it should talk about the external data that we are searching for, and then it should fine tune and come back to the LLM, and then it should post it, right? So meaning this RAG technique will be applicable in the relevant content that we are trying to retrieve the data while retrieving the data.
Yes. So as I said, okay, to answer your question, right, it is basically to influence the final data that you are trying to get from LLM. So when you ask LLM, it may not have the relevant information about the thing that you're asking for, because those are like information about some internal information. This is not generically available in the internet. If this data is generically available in the internet and the LLM has been pre-trained on it, you don't need to probably use RAG. But it's not the case always. Everything is won't be on the internet or the resource, the open resource that LLM has been trained. You need to pass that additional knowledge to LLM so that it has the whole information about the content it has been already pre-trained, and it adds this new relevant context and it gives high priority to this whatever that you are passing on to it. So it's basically it gives this keeps this on top for its knowledge, and then it generates the final response to include whatever the content you are giving in the RAG.
Got it. Okay.
Cool. Okay, so let's move on. Now we understood about how LLMs work, how it generates the content irrespective of the modality, how it's get into generative AI to use those LLMs behind the scenes, and how it's able to basically do an act as an agent. So let's understand the agent now. So we said that generative AI generates the content, whereas the agents, beyond generating the content, it can also take actions being autonomous. How does it happen? Let's look at this MCP, which is like the common protocol coined by Anthropic, so that one can actually use multiple LLMs, multiple foundational models, and with your own tools and databases, and then finally come up with a very effective, beautiful application out of it. So what does it mean is, to do the RAG, for example, we in the previous example we just said RAG. Fine, you said link your database and pass that knowledge to LLM. Nice, it looks nice in the picture, but how do you actually do that? And if you have multiple such databases, for example, you have results database and you have projects database and you have employee database and you have many other database where you need to feed in all that information to generate the final quarterly results table or report. So how do you link multiple databases? How do we link multiple API to fetch the data from the databases to feed it to LLM? This diagram is very, very abstracted to give very simplest knowledge about it. But how does it happen in real world? Let's look at this framework. So you have your resources like your PDFs or some user profiles, your employee profiles, or the project profiles and everything. And you have tools to basically do, get that information as stored information, your databases or something here. And then you have other APIs, so other microservices that you have in your company. And with all that, to link all these to LLMs and then finally generate the response, you need this MCP layer, model context protocol. What is it? How it helps is, it helps to join multiple multiple foundation models. Like you may want to use ChatGPT for generating an image. You may use Amazon Nova for generating a reel. You may use another model for a different calculation or something. You need all them together in one single place to do some application, deliver some project probably. And with that, you also need to link your own API, your own frameworks, packages, services, all that. That's where the MCP layer comes into picture and then stitches everything together. So this is very, very effective in terms of so that you can actually join all this together, do RAG, and then generate a final response using your prompt here. So the prompt is inevitable. You need to give the prompt, and you need to RAG with all these with the help of MCP. That's how you're able to accomplish your complete project. For example, just to give an example, you have a huge code base in your company, and from the company, you wanted to generate a documentation for the entire code base. So you give your, here it says GitHub, but it could be your Git repository, or you could give your some PDF files explaining the high level architecture about the code. and then you are giving the linking your databases and microservices where your code lies, or another your pipelines works and everything. And then you are giving a prompt to say, hey, can you generate a dynamic documentation with flow diagrams, architecture diagrams, and then explaining how each use case works, with sequence diagrams. And that's what you're giving the prompt. And then finally it's able to generate that. This one use case that the company can use. Similarly, there are multiple such use cases. This is another representation, just an example, like you are giving your MCP, your database, your GitHub. Sorry. Okay, can you please go on mute if you are speaking out? And you're linking your Slack and email. That means you're generating all that information, and then you're sending a link to your Slack so that someone can access it. Similarly, you're sending an email once this document has been generated. So you link you to your Gmail or Outlook. So that's how this MCPU helps here. So we discussed about multiple layers of how we can use. There are limitations for LLMs and what we need to consider. We discussed this in more one way or the other, knowledge cutoff. So what does it mean is your foundation model has been trying to certain date. Probably beyond the date, it doesn't have information about. That's where you need to give, you need to retrain that model if the content is generic content or public content, or you need to give RAG if it is a private content. Confidential content. Then second one is hallucinations. So in the sense that, see, when you're saying you generate some content, it would confidently say, hey, this is the content that you're looking for. For example, generate an image or a video that, say, for example, Bill Gates and, generate a video that Trump and Narendra Modi came into an agreement for some coalition. It would actually shows that that they actually did this. So that's and it may ask that, hey, did Narendra Modi and Trump get into some kind of a coalition for some new program? It may say yes, they did, based on the information of different programs they both have interacted. It could say that yeah, they went into some coalition for a new program, which is hallucination, which is incorrect, which is false. So we need to validate that always. Length limitations we discussed. So the input size and output size, they obviously depends on their cost. And one of the important problem till some time, I think that is changing now, is structured data limitation. That means you give, a complete book and then ask the LLM to, summarize it. It can do. But if you give a database table and say summarize it, it may not able to do, because the LLMs does not work on the structured data. As I described in the beginning, LLM converts the words into tokens, tokens into mathematical forms, and then it stores into vector DB. Here, there are no words, no tokens in the structured data. These are all like tables, columns, and stuff. So it's hard for LLM to process such kind of a data. But there are some techniques being added on top of it to help this. This is not a generic kind of an LLM. There are, tailor-made LLMs for such kind of a data. For example, Bloomberg GPT is one foundational model which works the great in terms of the financial calculations, because it works on these tables and stuff specifically designed for it, something like that. And potential biases basically depends on how you pre-train your model. It may get biased on that. For example, if you pre-train your model only on certain technology, like the example last time I gave, like if you pre-train model saying that Microsoft Technologies works a lot better than Google Technologies for the same purpose, it may bias the response finally, depends on your training data. So that you need to be very cautious when you're actually using the results in some application. So we covered this in a way or the other because this token sizes is basically different. The diagram here shows each foundational model built on how many number of tokens. Like say, for example, Google's BERT is built on top of 3.7 billion tokens. It's learned over 3.7 billion tokens. Similarly, Facebook here is 180 billion tokens. So there's a big science from Bloom. Bloom from Big Science, and it's learned or pre-trained on 366 billion models or tokens. So the bigger the number of tokens are, the better the responses are, the number of domains it can cover. So we discussed already the best practices in terms of how you do the prompt engineering. Okay, I'll just pause here. This is this we had to discuss about the roles. But if you have any quick question, we can take up that question and then go into the roles, which is the final topic of this session. Okay, I see that now. So I'll quickly cover the roles. So please pay some attention to it. So far we discussed a lot about how LLMs work, what LLM can do, what are the next steps, what is the future, what are the different techniques available to improve the prompting and as well as generation of the response. But who uses it? Where is my role there? So do I need to learn prompt engineering? Do I need to learn RAG? Do I need to learn fine tuning? Or do I need to understand what models work for what? So this is a big space. Understanding the roles would be better for you to better, place your role and goal accordingly. So predominantly the roles here are, I'll skip to the slides and then come back explaining. The first role is basically the end users, which is like indirect end users and direct end users. And other one is the solution architects and developers of the applications based on the generative AI and then LLM models. And the third one is AI model builders, like the ones who actually builds the foundational models like ChatGPT and all. And the fourth is the hardware enablement. So without the hardware support, it's all not possible. So what is the role of the hardware engineers in it? So these four are the key roles that we need to see where we fit in, right? So let me explain quickly in simple forms. So indirect end users is everyone under the sun. It could be humans, it could be animals, birds, or anything. So one way or the other, they get impacted by this generative AI. And the direct end users are those like the businesses and the individual persons who wants to use the LLM for improving their work. For example, teachers to summarize their classroom examples or generate classroom examples or prepare a story based on given certain criteria, or influencers to create the reels based on certain given information rather than they actually work day and night creating the reel or the PPTs and stuff. So those are the direct end users. In fact, this PPT has been created through the generative AI with some information given to it. So the other role, I believe this is the biggest space in the world of generative AI and where many people can actually find jobs and then create jobs basically. Because this space doesn't require a lot of coding information. It requires a certain level of coding information, but it's where the lot of money and the opportunities lie in, which is basically the solution architects and developers. Means the end users don't know how to integrate the generative AI for their purpose, specific purpose. For example, if you are building a suppose the requirement for the photo studio, for example, there is a photo studio or a digital studio. They wanted to generate a speaking album with all animations in it based on the pictures from the marriage or an event, and then they wanted to build a album of it. So they don't know how to probably use LLMs and generative AI. They are the businesses. So the role of the solution architects and developers here is they need to identify the right model for caption generation, the right model for image generation, the right model for the animation generation, the right model for, say, combining the videos, then use MCP and then bring all these models into MCP framework. And then they also feed in the database of a user database like their marriage photos or anything. And then they give some names of them like that. So build that framework and then generate the tool, generate the speaking album. So that's a solution that we need to generate for the end customers. I'm just giving one example. There are like infinite number of such examples that we can create. No one need to ask even. So we'll see, we can go around and see the businesses, what they need, we can run a generative AI based application creation business on our side, and then we can create n number of such roles and opportunities. The third one is generative AI model builders and researchers. This is a very niche area, currently being with only a few top companies like who are building the models, like OpenAI, Google, Amazon, Microsoft, Facebook or Meta. So this way, the generative AI engineers needs to understand a lot of machine learning models, how the machine learning models works, how deep learning works, what is transformer architecture, what is vector database, how it works, and all the different algorithms, and how they can actually pre-train effectively with less data probably, and then how they can get the prompt and then effectively generate the response. They can all do the fine tuning and everything in the generative Gen AI engineers. And the application developers here is basically they build the frameworks. For example, MCP framework. The home framework needs to be created to use across multiple models and applications. Who do that? So those again, the application developers who think about such frameworks, and the research scientists who relentlessly work on new technologies and evaluations, like say, as I said, generative AI, and then artificial general intelligence, and then super intelligence. Like there are research scientists who are actually working on the advancements of this. And the final one is the hardware enablement, like the chip designers who improve the chip density year over year, the aspect ratios and so on, and how much number of billions of actions that they can take to act on such number of 366 billion tokens, 160 billion tokens. How do we train them? So we need the hardware power for it. So this is another role. So for these roles, what do you need to learn? I think eventually coming in to say, hey, this is all nice. What exactly I need to learn for this? What I need to focus more on? So I'm not focusing on many other areas, but here I'm precisely focusing on this area, these two areas. One is that solution developers and application engineers, and the model builders, because the end users, of course, I believe we are not that category, at least the participants here, and also not the hardware enables. So I'm focusing on this here. So you need to understand all the LLM models and their capabilities, like GPT for text, Nova for video, Bloomberg GPT for financial content. You need to understand which model works for what. And then you need to have moderate programming or integration skills, because once you start integrating with MCP, you need to be able to integrate with LLM ops, and then integrate them all the applications from the company and as well as models, do LLM ops or ML ops, and then create the final application. You need to have the fair amount of knowledge on it, and the deeper knowledge on how LLM tools on frameworks exist, like the Copilot and Klein for code generation, and then understanding the code and so on. So Bedrock, Amazon Bedrock, is basically to build such applications as a framework. Firefly is basically if you wanted to build applications in terms of video generation and image generations. Yeah, Firefly is a good LLM integrated application. So there are many applications. You need to understand those applications to use them for your purpose. And then you need to obviously learn prompting techniques, because after you build all that, you need to give the effective prompt so that the result is perfect. So you need to understand the prompting techniques for sure. So zero shot means no specific examples needed. Few shot means you give few examples. One shot means you give one example other than your prompt. And the chain of thought is basically, we have done that already in this example today. You give one prompt, and then you are giving another thought to the prompt, and you are giving another thought to the prompt, and then eventually you're getting the result. So you need to understand those techniques. So, and results, you're influencing result with examples means you're giving more and more examples, how the result has to be modified in the prompt. And yeah, you need to understand fine tuning and RAG. Basically, you need to feed in certain new information to the LLM model through MCP protocol. So you need to understand that. And what are the frameworks available, to use to build agents, LangChain and Hugging Face. You need to understand knowledge on it. Yeah, so basically, like the multiple agents, how you can have some knowledge, like if you want to use Microsoft 365, how content has been generated based on the LLM models in within Microsoft 365, you can potentially have some IoT techniques. It's not only working on the laptops, because if you want to build a generative AI application which needs to be deployed in some farming or industrial areas, you need to have IoT techniques as well, so you can integrate into that aspect. But if you want to focus on the model builders area rather than on the solution architects, application developers, you need to understand the base algorithms, machine learning deeper into it. This is a niche area, but this is the heart and the core on top of the jobs that's getting high paid at this point. So about building the models, understanding the transformer architecture, what are the diffusion models, how they work, and how can we improve the diffusion models to speed up the image generation process and the whole LLM model building life cycle. Yeah, this is the order of that. So I'm not going into deep each one of them in the interest of time, but if anyone have any question about this LLM life cycle, yeah, I'm happy to go deeper into it. Okay, so I'm done for today. But over the entire presentation, if you have any questions, I'm happy to take questions.
So, hi Suresh, Veeresh here.
Hi, Viresh.
So, the overall summary of this entire course, it will lead to the proper role of the solution architect and developer, right?
Yeah, so maybe Venkat would talk more about that, what would be part of that course, because the majority area would be this one, the solution promoters and custom application developers. But this is where you would understand the different LLM models, different frameworks available, different LLM integrated applications available, like Copilot and then Bedrock Client. So how do we improve your prompting so that you can use that in build to any building application? So the area it focuses on that this particularly. But if you want to focus on this area, the model builders, so that's way different because this is something that we need to go deeper into the ML techniques and then algorithms on all this life cycle and so on. This is basically if you wanted to find yourself into the actually model building into the big tech companies. So this is the area that would be helpful. But otherwise, I highly recommend this area to be very hands-on, and that's where the whole course will be focusing more on. Having said that, we'll also can cover some of these transformer architecture, tokenizations, and those things even in the previous one. But we won't go too deeper into how LLMs, how machine learning models have been generated or prepared or created, kind of a thing. Is that answer your question, Viresh?
Yeah, so I am a bit not clear because how this is going to help us to build a use case or find out the business requirement and how we can fit our business requirement into it. So that
You can probably give an example. I'll tell that how it works.
see, I'm working in a bank domain. So
Okay.
whereas we have entire secure area, right? So all financial data should not go out. And there are n number of opportunities whereas we can do this, use this Gen AI or the artificial intelligence, right? To
Right.
uh,
So to answer your question, right, for example, the financial reconciliations that you do, there's a lot of manual work that goes into the financial reconciliations. So what are the overall expenses? What are the overall investments? What are the long-term, short-term investments? What are the where are the ledgers happening? These are all used to be very manual, and then we were using some of the individual tools to operate to use all that. But with this, when you get into this area, understanding this AI solution promoters and custom application developers, you will understand how to use MCP model. You will understand how to use, say, for example, Bloomberg GPT kind of a thing to use the financial calculations. by integrating, for example, say you have an MCP framework, you understand that, and then you bring in Bloomberg GPT as a core foundational model, and then you use Python to basically to query your own applications, like say the confidential information that you have within your own environment, and then you can use Copilot to basically build quick Python modules or something to query the content from your tools. And then you use a prompting technique, say how the reconciliation has to be generated. So this is the space entirely helps you to automate the entire thing in your in banking applications, and then reconcile all the financial transactions.
Okay, if you want to stitch it with the IT, overall IT infrastructure, how it will help?
Okay, you are seeing a different example now, IT infrastructure, right?
Yeah.
Okay, so not the banking, but the IT infrastructure. For example, if you take an IT department, so what does it goes in like? So there are different IT tools, softwares, and then hardware that you actually operate with. You do a lot of troubleshooting on these tools, softwares, and then hardware, and there are a lot of different techniques available. So by actually integrating LLM using MCP and other your internal tools, you can auto generate the troubleshooting steps for a particular situation. So it's rather than IT engineer going in person and then helping each one. So given certain inputs from the customer, then the LLM can actually generate the final step-by-step resolution for your domain specifically based on the inputs you are passing, based on the previous tickets that you are sending to it. For example, there are like hundreds of tickets that you have addressed in the past. You pass all the tickets information to LLM, which is like all the ticket information is your RAG, and the LLM basically core foundational model exists anyway on top of MCP framework. Then this model understands all the tickets and then create patterns out of it. Okay, is your problem about Outlook is not working? Go through these steps. Is your problem is like your Wi-Fi is not getting connected? Go through these steps. So, and within the steps, you have the company information like, okay, use this as a public guest password or is a private password, private Wi-Fi, guest Wi-Fi, all that information can be going in. This is one example about reducing the load on the troubleshooting, but there could be plenty of such examples you can do.
Oh, Paresh, I think it answers your question, right? Yeah.
Yeah. Thank you.
Yeah. Well, and tomorrow also we have a session, so we can deep dive what is going to discuss in our regular course. So
Sure.
any other questions, guys, as we are running out of time? So any other questions to Suresh?
Venkat, no questions for Suresh, but can you, like tomorrow in class, can you explain the curriculum that we will be covering in next coming months, so that
That's
that will
the
be
plan for tomorrow's session. Yeah.
okay.
Tomorrow's is more of introduction and what we're going to cover. That is be there in the next session. Okay.
Okay.
Tomorrow.
Okay. Thanks, Venkat. Yeah, that should be good.
So this is more of completely trying to understand what is
Yeah.
overview of the AI. Okay. Yeah. Is there anyone from anyone else? Any other questions? Okay. I'm taking it as no. Yeah. Thank you, Suresh. Thanks a lot. It is full insightful and informative demo. So it gives us complete understanding of the concepts. And thanks everyone for attending the demo. Appreciate your time and the participation. So guys, just a reminder, we have very limited slots. We already 10 plus registrations. As you all know that we won't take many people in our classes. So hardly it will be 15. So very few are left. If anyone wanted to join, so please complete the registration at the earliest. Yeah, thanks everyone. Thanks a lot. Thanks for the participation. So have a nice weekend.
Thank you. Same to you. Thank you.
Yeah, just a reminder,
Venkat,
tomorrow we have a
also
session
same
at,
timing,
yes,
9 to
tomorrow
10.
also we have a session at 9 to 10.
Yeah. Okay, Venkat.
So
Thank you.
that I'll update in the group. Okay.
Sure. Thanks, Venkat. Yeah.
Thanks everyone. Thank you.
Thank you.